Hello and welcome to this next video explaining ABES geometry control software. In previous editions of this video series we have already introduced an axis into our getting started project, and we have defined a simple cross section, and we will now continue and extrude this cross section into segments. We will define two different types of segment: the pier segment, which is a base segment cast between two bulkheads, and the cantilever segments for our example, which will be match cast against the pier segment. Let's start with the cantilever segments. We know the proceedings by now. Right click onto the segment folder, insert a new segment, and we call it cantilever segment. We can choose between different types of segment, and we will choose a precast segment here, and this leads us to the segment input dialog. A good way of visualizing the process here is to think of a segment as an extrusion of the cross section we want to use within this segment. And as a first step, we go to this window here, right click, and we select our cross section that we want to extrude. Now we only have one cross section, the one that we defined earlier. It's called box simple, and we are going to use this one. We want to extrude this cross section with a length of 3 meters, and we want this segment that we now create by this extrusion to be a match cast segment, and we want the program to determine automatically on which side of the segment the bulkhead is going to be. Remember, we are casting in two directions, and depending whether we cast upstream or downstream, the bulkhead will be on one or the other side. We also want this the segment center line of this segment we are creating here to sit on the axis, which is quite curved, as we remember, as a secant. So the segment center line is a straight line, and that straight line of the segment center line will be a secant to the axis, which means that the starting point and the end point of our segment center line will sit smack on the axis. Of course, since the axis is slightly curved in between the start and the end of the center line, the axis will deviate slightly from the center line within the segment. There is one more definition we have to do here, and that concerns the control points that we have defined in our cross section. Remember, there are 3 control points: A, B, and C, and I've just made the decision to use all 3 control points on at the start and at the end joint as control points. We should name these control points so we can keep them apart from the start and at the start and at the end, and we can easily do that by automatically naming all control points that we have activated with these tick boxes. The program has now invented names: A sub 1 for the starting joint of the segment and A sub 2 for the end joint of the segment. If we don't like these names, we can change them, of course. I'm going with them. One more definition I'd like to point out: this is the value by which those control points will be set into the segment, the distance that they will be set into the segment from the joint. In other words, the control points here at the start will be set 100 millimeters into the segment, measured from the joint, from the starting joint, and the 3 control points at the end, these 3 here, they will be set into the segment by 100 millimeters from the end joint. This already concludes our inputs for the matchcast segments. Accept, and the data is stored in the database. We will repeat this process now for the Pier segment, except there will be some small changes along the way. We insert a new segment. I call it the Pier segment. It's a precast segment, and here we are back in the input dialog for segments. I will split this Pier segment into two halves. The reason being that I want the Pier segment to be connected to the pier right in the middle of the Pier segment. So I will split the segment into two halves, each with a length of 2.5 meters. So I start here by choosing a cross section again, box simple, and I'm extruding this cross section by 2.5 meters for the first, what we call sub-segment. I then choose the same cross section again, and I extrude it for another 2.5 meters to form the second half. Now, this segment at the pier will be a base segment. Base segment being a segment cast between two bulkheads. It's a starter segment for our casting sequences. And because we are on such a tight corner, such a tight radius in plan view, I think it makes sense to put the pier segment as a tangent onto this axis, so that the bearings, both bearings, are on equal distances from the axis when we build the bridge. So I'm choosing a tangent here as my rule to place this segment. Then that means that the start and the end of my full pier segment will be slightly offset laterally to this curve of our axis. Let's go back to the first subsegment here, and I'm activating the control points at the start of this first subsegment. I let the program determine the names again, and I go to the second subsegment and I activate the control points at the end of the second subsegment, and here are my automatically created names again. One more point action to do. I will choose the connection point tab here, go back to the first subsegment, and at the end of the first subsegment, which is in the middle of the segment of course, I want to activate my connection point X. Remember, when we created our cross section, we also determined a connection point and gave it, this point X, the property of a connection point, and here it is again. Program will name it X sub 2, and in this way we have now created a connection point for this segment in the middle of the segment, 3.1 meters down from the road surface. That's all fine with me now. We have done all the inputs, we have created the pier segment. One thing left to do is accept and close the window. As always, if we want to have a visualization of our input, it's a good idea to right click and ask for a diagram, and this is what we get. In this case, for a segment, we see our pier segment. It has two halves to it. There are 1, 2, 3 control points here on the one joint, offset by 100 mm from the joint. 1, 2, 3 on the other side, again offset from the joint, and here in the middle we have our connection point where we will be connecting this pier segment to the pier top. There is also coordinate systems and other information in this drawing. We will get to that in our time. This concludes our fourth video in this series about ABES geometry control software, and I would like to welcome you again in the next video, where we will be talking about segment groups.